Alright, another draft physics presentation. So it should be on a few subjects. It's probably going to start though, so I'll title it consistent with that series on the idea of the drag problem for movement in the universe. Alright, so the art whatever guy has made another comment, so I'll read that. But first let's preface this with an understanding. Regular physics, conventional physics, has absolutely no explanation for material velocity. They don't account for it at all. They just establish that somehow once you make something start to move, it keeps moving. Now, electrons won't do that, and protons won't do that, and even neutrons won't do that. You can't shoot them somewhere. We'd be using them if we could, but we can't shoot them somewhere. They won't do it. They won't cooperate. And so just understand, they have no ability to go a distance at all, even in a very low atmosphere or even in space. So you can't send electrons to a satellite from another satellite, a beam of electrons. This stuff doesn't move. It doesn't just go and keep going. And physics has no explanation for why that is. And matter somehow, certain clumps of matter, will just keep going. They don't have an explanation why, say, hydrogen doesn't keep flying through space. Just, gets blown off of things and a bunch of hydrogen atoms should be hitting us, but they don't. From stars that blow up or something. They fall apart if they get here. And they turn into maybe an alpha particle, which would be the helium nucleus, which I drew. So to my explanation, I started with the thing we know, the smallest thing we know that has perpetual velocity. That is, it can travel billions of miles through space, and it doesn't slow down. And the only thing we know does that I know of, the smallest thing. The smallest thing we know that can do the perpetual velocity thing that could be considered material is the helium nucleus. So again, let's just understand the context here. Conventional physics has no explanation for inertial states, of velocities. It accounts for them by just saying, once you make it go, it'll just keep going unless something stops it from keep going. And they don't explain how the little bits, all the nuclear bits inside of the thing that they know exist, all the atoms, all the electrons, and all the protons somehow know they have to keep moving. It's perpetual motion, and they don't explain it. Now, I'm arguing for a perpetual motion machine, but I'm explaining the mechanism. So let's just understand, they have no mechanism. They don't account for any of it. So it's a context that should be understood. People are going to argue against things so aggressively when they have nothing as a counter-argument. Nothing. I mean, that's worse than a religious kook. It's worse than a religious kook who denies evolution. Because at least, okay, they have some kind of wacky theory. These people have no theory of velocity, material velocity. There's no theory. Okay, so in that context. So Superior Mind commented basically saying, gee, that art guy's kind of a douche, put simply. And so the art guy responded, you are such a dishonest cunt, it's actually disgusting. Whatever, Superior Mind's a pretty cautious talker, but regardless. So he quotes a little bit, and he says, take a look at what he says at 425 about a pendulum dip fuck. Yeah, I made the argument. Now, if you don't think it's possible, then explain why. I mean, obviously the pendulum clock I was talking about isn't one in gravity. So gravity's not what creates the motion. So put the pendulum clock in space and have the idea that the pendulum, once initiated with motion, behaves like a photon. It just keeps going. So it has perpetual motion. The pendulum has perpetual motion. And what would be the consequences of that motion is the argument. And clearly with a pendulum, the constriction on the swing of the pendulum is the bar and the joint that the pendulum's on, and that would equalize the force. But it still wouldn't account for the fact that if the pendulum actually hits the material object kinetically, that those impacts are going to mean something in terms of motion in a direction. Alright, what do you think he is saying? Question mark. What do you think he is arguing for? I clearly pointed out what I was arguing for. I said, I even drew a P. Okay, do I still have that piece of paper? I mean, I even drew a P on the piece of paper. Yeah, I did. Right. Oh, we're not on the... Well, I drew a P and then said dot E. Perpetual energy. Yes. I'm saying that inside atoms you can create such a mechanism, and that is what maintains material velocity. I'm actually explaining why things move, where you have nothing as an explanation. Alright, he's literally trying to argue that a self-propelling configuration is possible. Yes, in the nuclear universe it's possible. In the frictionless universe where photons and electrons and protons and neutrons live, yes, it's possible. And he is directly trying to argue this is tied to his resolution for drag. Obviously, it explains how a material thing can move. So yes, that's what it is, an explanation. I provided, as you harassed me for the mechanism, I've come upon a mechanism now. I gave you a vague idea of it, okay, and you didn't like the vague idea, so yeah, I worked a little harder, and now I have an idea that I think it's certainly an improvement. Might not still be perfect, but I'm saying challenge it with some kind of fact. You don't have a fact here. You're not making an argument. Alright. Resolution of drag. Arrogant cunt. Yes, so all of that is just a straw man, because quite obviously superior mind understands, yes, that's exactly what I did. I showed you a perpetual motion machine in nuclear physics. I can't believe someone has to keep typing this shit to hold you lying scumbags accountable. So in what way has anyone lied here? So go ahead, prove the lie. Where's the deception? Oh, helium nucleuses aren't made out of 2 neutrons and 2 protons and 2 electrons, essentially. That's not the configuration, 2 neutrons, 2 protons. That's not accurate? No, that is accurate. Anyway, it's just disgusting. You know, where's the lie? Why don't you demonstrate one of the accusations you make? Why don't you back one of them up with a piece of evidence? It's inconceivable people can be such disgusting dirtbags. But every fucking time you people amaze me. Well, so what? I mean, I say the exact same thing about you people. What is motivating you to be this obnoxious, this rude, when you're not making any argument at all? There's no argument here. There's just, you're upset because I'm challenging your religion. And that's it. You're devoted to a notion, and this looks like it might challenge it. And that's what you're afraid of. And it's hitting all kinds of desperate buttons inside of you, like the girl is going to see how small your penis is, and you're panicking. That's why you have to resort to these bizarre accusations that somewhere I lied about something. Fuck, you're retarded. Does his theory follow conservation of momentum, or does it not? Well, why don't you answer that question by proving how it doesn't? Of course, I'm asserting it. I've said it directly 7 million times in these videos. Okay, it's not 7 million. That would be a lie. Over and over again, I have asserted, I have even pleaded with assholes like yourself, if you can find a violation of the conservation of energy or momentum in my theory anywhere, please point it out. That's exactly why I'm presenting it. I'm saying this answers the questions in physics, and I've plainly stated that any theory has to obey the laws of conservation. Duh. Okay. So I'll read whatever his quote of Superior Mind's quote of him. So he said, Art Vandelay, the obvious fact that most of the matter is not moving forward, including protons. Obviously, my assertion wasn't that most of the matter doesn't move in the direction that's necessary to the velocity. I'm sorry I didn't make that clear. Okay, what I was arguing is that some portion of the mass moves in the wrong direction, and that allows for the force to act on the other mass. But regardless, statement strikes me as dishonest, pretending not to understand. Well, I don't think he's pretending not to understand that part, so I'll give that to him, that yes, he could make the mistake. Perhaps, well, I don't think he could, because I did say it in the video, and it does seem a little bit logically intuitive that you could reason that clearly I wasn't proposing that things go backward more than they go forward. But anyway, either that or he thinks matter isn't made of configured forces. This is the issue, exactly. He doesn't think matter's made out of configured forces. So he doesn't think that matter is made of, that is, it contains photons, things with perpetual energy. And he doesn't believe that those perpetual energy bits don't interact with each other. That is, they can't be dragged. Photons don't experience drag. Even if I shoot photons right at them, they don't experience drag. If I shoot gravity at them, they don't experience drag. If I shoot magnetism at them, they don't experience drag. So he doesn't understand, or wish to understand, that the argument being made is if the matter has more force in it than mass as force, then mass as mass, other material mass, that the force mass can dictate the momentum of the object. Okay. Which we know it is. So I don't know what we can say what we know is true, but obviously one of the premises of my whole theory is that force is different than matter, but matter is actually a configuration of force. Alright, what's the forefront of a moving body, he says. What does that even mean? What's the forefront of a moving body? The point is you don't even have an explanation for why the body continues to move. Why, if I throw this pin into outer space, it will fly all the way to Mars eventually, or whatever planet it happens to be thrown at. You don't explain that. He said most of the protons don't move forward. No, I said exactly the opposite. Most of the electrons were going down, most of the protons were going up, but regardless. And most of the matter, and frankly that was the old, the exact drawing. I said, oh, I thought about it, and I said, fuck, that won't work. And I actually in the video threw the piece of paper and said that won't work. And you're still arguing it. There's a new argument being made. Catch on. Anyway, that directly means it is the force bits that have to be the same ones getting ahead of the matter bits. Again, force bits getting ahead of matter bits would sort of defeat the purpose of the argument. So again, the argument has always been about force being trapped. So it can't really get ahead. But anyway. Of the matter bits. But then they would get ejected out at the speed of light. And you say they'd get ejected out. My point has been from the very beginning that you can obviously trap energy, force bits, in matter bits, and batteries, for example, do that. Or are you going to introduce yet another mechanism here to save your ass? So again, you haven't argued the mechanism on the table. We don't need another mechanism until you defeat the one that exists, and you haven't argued any single point of the mechanism presented that's on the table now. So deal with what's on the table now. Okay, and then act as if that's what you and your buddy mean all along. So again, I couldn't have made it more clear. This is a DraftScience channel that this has been a problem I've been working on for years, the drag issue. I've had ideas. I said explicitly in videos, I said some of those ideas sucked. These weren't good enough. I said they weren't good enough at least 5 times in 5 different videos. I've pointed out it's not good enough. I gotta do better. I said those exact fucking words. How can you not be seen as an asshole here? Now, I said, I drew on the paper, where did I put it? What did I do with it? Interesting. I just had it, because I was going to use it as illustration. Where's the old drawing? That's bizarre. I had it in my hand. I put it right there in front of me. Oh, here it is. Okay, so I've got to keep this one straight. Well, that's right. I said it doesn't really matter showing you the PE part, but I will show it to you. Right on it, I wrote, looks good. I like it. Now, why don't you argue it? Okay, so I'll get to that now. I'll get to the new drawing. Oh, there, it's the whole time, so good, you saw it. So let me put this back up. You didn't need to see the stupid comment anyway. There, it says, looks good, I like it. See? P. I wrote P for perpetual energy. Perpetual energy. Here it is, right there. So now, that looks a little messy now, because I drew over it. So here's the basic design. And so the idea is this is the pendulum. And the pendulum knocks these neutrons forward, and the fact that they have repulsion to this proton means the proton goes forward. So these 3 bits are pushed forward, and this is the energy machine here. This motion going back and forth knocks these forward. Now, the interesting bit is, obviously this is the fulcrum of the pendulum. So where the pendulum would be, the fulcrum would be here in a pendulum swinging this way. And one could argue that the motion, the torque of bending the path of this crooked, that torque would pull down just as much as this would hit up. And that's probably not entirely true, but regardless, let's say that was true. You could argue that this mechanism has that same problem, in that as the energy goes in here and gets turned, that the torque down would be as much as this torque this direction. But again, let's understand, this is just turning. Alright, so it's a different mechanism. But regardless, let's say that was even true, that actually is happening. The proton is getting pushed down just as hard as these electrons are getting pushed up. The tricky part, the part that's interesting, is that you have to remember that the proton and the neutron, the proton and the electron, have a force, sort of a spring force, so to speak, pulling them towards each other. So as this electron moves up, this proton commensurately moves up because of that spring force. So that is compensated for, in the sense that and all the springs don't have heat, of course. I'm just using spring as an example of the fact that there's a pulling tension between the electron and the proton, pushing them together. So if the proton moves away from the electron, it will be pulled back by that force, and that will undo the force that pushed it down. And so you really just have, so if I just made this machine, so the interesting thing is, if you just think of this proton, and 2 electrons, that I believe it's not deuterium, well anyway, it's one of the isotopes of hydrogen. But anyway, but if you just thought of this as, let's just cut this part off for now. That's these 3 protons. So let's just take these 3 protons and remove them, and you just had this device. And let's say there was some reason it stayed in this position. So the energy would go in, push this electron up, and then go back through here, and then push this electron up. And in that process, this proton would get pushed down. And you could argue that that machine could go forever, because there's no losses in this path. So there's no friction. So just understand, no friction to slow anything down in here. So if that was happening, you could say, yes, that thing would just stay in space and it would jiggle. Now the point is if I take that jiggling thing and tie it through the tension created, the attractive tension created between these 2 electrons and this proton, and these 2 protons that are the part of the neutrons, but anyway, and their tension, then this thing that's just jiggling will essentially, when I put it next to this thing, it will push this thing forward. And because it's tied to it, in the sense it's going to pull it towards it again, it'll hit it again, and then it'll hit it again, and then it'll hit it again, and then it'll hit it again. So this, if you break the two mechanisms in 2, you can sort of understand that yes, these 3 are going to get pushed forward, this one's going to get pushed down, but it's also going to be pulled back by the 2 electrons that have been moved forward to hit the neutron. So let's just understand, they don't actually hit it, they just create pressure, but regardless. Alright, and the other thing I noticed was this works really good in a lot of ways. So the more neutral, that is the further down, like equidistant here, I put this electron, the more balanced these force lines get. And you could almost imagine that any energy going this way would be maintained, because this specific arrangement would be held in place. So in a sense, you could argue that there's black energy going around this whole loop on this other side too. And so this energy would be countering, in a sense, the energy down. So you'd have to have more little bits here than bits here for the thing to move forward. And that's not a problem at all. But a catch is that as this mechanism starts to work, that is, the more you push these electrons forward, the more the shape breaks down, and this path, you can imagine this proton getting kind of closer, and therefore that path would no longer be viable for the black energy. It would be set free. So and the other catch is that when you're thinking about the force coming in, okay, so you're hitting more force this way from the field, pushing down, but you're putting more energy in here, pushing up. Now the catch is, the more you move these electrons forward, the more you change the ratio of exposure to the electron. So now you can, so you're sort of got to understand that somehow you have to get force in between this electron and proton that's bouncing in this direction. In a sense, you could say it's got to have a reflective angle, okay, that creates that event where something comes in one way and it goes straight perpendicular across and then gets trapped going back and forth. So it comes in at one angle, gets trapped going back and forth. Now you can sort of see that the further these electrons are forward, that is, the more force is bouncing this way, then the exposure for doing that increases, where the exposure from the environment to do that, that is, for force to get in here and bounce between these two and get caught in this cycle. So that you have to understand there's 2 closed paths, this path and this path. And to get into this path, you have to hit the electron. It's the only way to get into the path. So the only way into this, the only way that this can collect force, the force has to hit the electron to get trapped in this cycle. And the only way for force from this end to get trapped in this cycle, it can't do it by hitting this proton or hitting this neutron. It has to do it by hitting the electron and getting trapped. And you can sort of see that the ability to do that, the more the electron gets pushed towards the proton, the less opportunity there's going to be for that to happen. So it fixes another problem. So I'm just saying that the more I analyze this, I'm not finding flaws. I'm finding more reason to think it's a good idea, that I'm on the right track, because the more I play with it, the more things it fits. So it's getting better and better as a perpetual motion machine. And it's perpetual motion in the sense you still have to put the energy in. You have to fill this with energy. You have to swing that pendulum fast. And you do that by putting more energy into it. And that's the mechanism that pushes it forward. So I put that on the table. There haven't been any comments at all relevant to this except that one. And the one comment totally ignored what I put on the table and just says it's wrong because I say so. That's not an argument, newsflash. Somehow it violates conservation when I've done everything I can to explain how no, it doesn't. It traps force, more of it going one way than it traps going the other way, and therefore it moves the way it trapped more force going. Yeah. Okay, so I think that's it for that subject. Alright, so there was a couple other things I wanted to get to. So the next one is Feynman. So I guess we could, we'll play the clip and then I'll add to it, I think, with a drawing, maybe. I don't know if a drawing will be necessary. Maybe I can just explain it. It's just something I noticed, so it's a different subject. So this one's more back on the interferometer stuff, sort of, indirectly. And, this is a lecture I've seen, I don't know, 20 times. I mean, it's one at Auckland, New Zealand, or whatever, it's 1980-ish. And so he was asked this question. Now, in the past, there's a previous video where I played this clip, from like 3 years ago or 4 years ago, and I was sort of, oh yeah, that's the way it is. You cheated the argument by not acknowledging that and all that stuff, and now I'm actually going to say he's got it wrong. So where I thought his answer in the question period, I thought fixed a problem he didn't address in the actual lecture. So this is in the question period after the lecture, and somebody asked him, have you left anything in this lecture that you need to fix? So let me get the right thing up. Alright, it should be working, hopefully. I got the volume all the way up, but I just don't, the volume's a little bit low, so I'll try not to talk over the video.
Have you left out anything in this lecture which you need to add later?
It's very difficult, and I worked very hard on the lecture to try to use as my examples things that I didn't have to change later, the interpretation slightly. I couldn't get an elementary enough process that I didn't have. Later on, I have to make a little change. You see, we talk and we see as though it's reflected at the surface. Actually, what's really happening, and with a deeper understanding, which I should do later on in the lecture, I might forget, is that it's reflected, what caused, it affects electrons in here, which re-emit light here, or here, or here, or here, or here, or here.
Alright, that's probably enough of that for now. So you get the idea. Okay, so what he was really talking about is surfaces and light reflecting off surfaces. So this is sort of back to the interferometer argument in the beam splitter, because we're back to internal reflections. And I would argue that this is a really important part of how interferometers work, in terms of what's creating the rings. Alright, so back to the videotape, so to speak. Well, whatever, the bad drawings. Yeah, just have to do. So the idea is, so he uses this whole clock mechanism. So we have a pattern. Alright, so the pattern goes like a sine wave. So this would be a 16% chance of reflection, this would be a 0% chance. And by polishing glass thinner and thinner, like just taking surface off the glass, you can change the reflective index of the glass from 16% at some level and down to 0. and it does it by this kind of a sine wave idea. So you could argue, if I don't know, you could say if this was 1 millimeter, okay, you could break it into a pattern and say if this was 2 millimeters and this was 3 millimeters thick. These aren't the real proportions. They're tiny proportions of glass you take off that changes these relationships. But you could sort of understand that at 1.5 millimeters and at 2.5 millimeters, these would be the points where there'd be zero reflection, and these would be the points where there's the highest amount of reflection off the surface of the glass. Alright, but the trick is the surface of the glass ends up being two surfaces. You can reflect technically off the top surface, or you can reflect off the bottom surface. So there's two chances for reflection. And the point is, it says I make this narrower, I change that percentage, and so Feynman uses this clock idea to say there's two vectors. You go around and around and around, and what this clock idea is just doing is it's just traveling this line and saying the further you travel the line, so here's your chance of reflection is this length of line, okay, the same source. So you have a shot of light, you travel this line and you go that far, and that's a vector. So you write that vector down, arrow this way, and then you travel this much further, okay, or this total line all the way to the bottom of the glass, and that would take you to some other point where your vector could be, well, this would be flat line this way. And then so you have those two lines, and the idea is you take those two lines and you place them on top of each other. Well, I guess I just did. No, you put them this way. Okay, so ignore that. You put them head to tail, and then you take this line, and the square of that is your area, or you can do it by drawing the circle thing. You can take the angle and just go around this, around the origin, and you draw this angle, and that's your probability. Either way will work. The hypotenuse defines your probability of getting a reflection. Alright, this is more than I really should go into, because it doesn't really have anything to do with what the argument he's making exactly, but I'm just saying I had to draw what he was. That's just a gimmick. Okay, this whole clock thing is just a gimmick to describe two different locations on this probability curve, and you're just making you're just adding the two probabilities in terms of a 6% here and a 1% here. That gives you a 7% chance. You're just adding them. So anyway, so that's what he presented in the lecture. So after the lecture he explains, so it'd only be two arrows, from these two events. So what he's saying after the lecture is, no, well, there's really 7 million arrows, okay, but you don't have to count these because it all comes out the same, because every one that adds more, there's one that subtracts more, so you really don't have to count them. And he's sort of arguing that the light doesn't reflect off the surfaces, that it in fact hits electrons in the surface in different locations and reflects. Now, I thought that was correct in the past. I thought that surfaces, it doesn't make any sense. What's the surfaces have to do with anything? But it can't be right, because we already know it's not right, because we know that internal reflections happen, and the internal reflections have they're specific to the length of the travel, that is the thickness of the glass. So you have this 4% chance, let's say if light goes through, you have this, 4 is the average percent chance of the light getting internally reflected is it's a 4% chance that it gets internally reflected, and then there's a 4% chance of that internal reflection leaving with each internal reflection. So each time it bounces, there's another 4% chance that it leaves at that location, and that's essentially what creates the rings. I mean the rings in different. That's the width of the ringed pattern you see, is the light is reflecting internally inside the surface. So the real argument is, I mean, the thing I thought I would add to this is you can think of this so many different ways, but anytime you have a transition between one medium and another, you have to kind of consider it that you always have three media. You have lots of surfaces, because you have the medium you're traveling through, and then the medium you're going into. And so the trick is where is the actual reflection happening? Is it happening off the bottom of this? Let's say this is air, and you're in air, and it's it's a big surface. Let's just say. I mean, we can make it much bigger, much thicker. Is it reflecting off the bottom of the air surface, or is it reflecting off the top of the glass? And I guess I would argue that it must be the top of the glass. So in every transition, the medium, because all of these have an index. Every medium has a different index of probability to create reflections and angles of refraction. So for each medium, those angles will be different, and the probability of reflection will be different. So I think the evidence indicates that the controlling medium is the new medium you hit. So it has to be that the light's reflecting off the surface of the glass, and then it's reflecting off the surface. Say this is air, so you have air on one side, air on the other side. The internal reflection is actually a reflection off the air and then out. That's the new index. So there's never really an internal reflection between the layers of glass. The internal reflection is actually being caused by a reflection off the surface of the air, this line, and the top surface of the glass. So it's the top surface of the glass and the top surface of the air is where the internal reflection is taking place. So anyway, I thought that was interesting. And again, it's just, you can sort of deduce Feynman has to be wrong about this, because this internal reflection thing is a real thing. Okay, it's, people in optics know it. And the more straight the light comes in, of course, the more the tinier the frequency, so to speak, the wavelength of these reflections, and the smaller the rings would be. And the more angle you put on how the light gets in, the wider the bands will be. And the thickness of the material would also dictate how thin or thick they'll be, because the thicker the material, the more time for these angles to become larger. A tiny angle becomes a big bit of space, the more the distance you travel. So there's two things deciding when you get the ringed pattern. And I've noticed the ring pattern, as I've sort of pointed out, the ring pattern doesn't do anything like the single slit, in that the rings get proportionally, the sizes get proportionally smaller as you go out. So that's a I don't know, defect, a thing you have to account for in terms of phenomenon that happens as you create wider and wider angles. That the amount, let's see how to say that. Yeah, I think I'll just leave it alone. But I'm just saying it's something that's part of this pattern. Yeah, I just don't have it clear in my head at the moment, so I'm not going to bother saying something that I'll say, oh, that was a mistake. So I just won't bother. I'm just saying it is a fact of the pattern that the rings don't diminish to nothing thinness as far as I remember, but they do have this obvious thing where the center ones are much bigger than the outer ones, and that's something that has to be accounted for. But that just might have to do with the angles as the light's going off at these different angles, the spread would have, because the distance is closer, yeah, that should go the other way around. So yeah, there's no point in me speculating on it because I'm going to mess it up. But anyway, I just thought I'd point out that it's another, I think it's an error by Feynman. And if somebody wants to tell me how it's not an error, I'd be interested to know how it's not an error. Okay, and so what's next? Oh yeah, I just wanted to, I think I'll do an email, I mean a PM. So let me put the good drawing back up. Where did I put that? Gotta keep all this stuff straight. Yeah, this is it. The new mechanism. And I won't bother showing you my PM because then I'll show the guy's name, and I really don't, I mean, I don't want to be rude, but it's just the kind of crap you get from people who are just playing these games. I'm just so sick of all these dishonest jackasses on planet Earth. Let me just check if there's any new comments while I'm here. No. Okay, messages. I mean, I didn't respond to this guy because it's obviously just bullshit, and you know, you shouldn't have to deal with bullshitters. You know, well, whatever, you'll get the point. So he said, "Hi, I've watched some of your videos. You are closer to the truth. You are closer than most to the truth. I don't know whether it will be good or bad news for you that I have written a theory of everything, really fact, in parentheses, a theory of everything, really fact." I guess he wants to say a theory of fact. Anyway, in which I explain absolutely everything, which, okay, it's a bold statement. I mean, it's, you know, I'd like to see it. To the current level of the model, which is 1.0. So he explains everything except everything. Oh, okay, everything's not included in everything. Only 1.0 is included. Oh, okay. The theory also explains the right system, society, government for true humans, which is metrocracy or something, and how to create it. Well, that's fascinating, but I just couldn't care less on this channel. See, I have another channel where I talk philosophy, but this channel I'm not doing that. And how it will take over the rule of the planet of the apes, and very fast soon from the moment it will start. Well, if you have all of this great stuff, why don't you get going on it, buddy? Anyway, my question then is, how much ego do you have about your theory? Will you be willing to join metrocracy, really start it? Well, why would I have to start it? He's doing this on a channel that gets, you know, maybe 150 views on a video. I mean, what are you, insane or something? Anyway, in the current system, of course, it's competition. Thus, my theory supposed to come. Yeah, it's not very well written. In the current system, of course, it's competition. Thus, my theory supposed to come on the expense of yours. I don't care. I mean, really, frankly, yes, if you can solve all of the world's problems tomorrow, please do it. I mean, thank you. That's so special of you. I mean, great work. I mean, you know, obviously, if you're going to do it by stealing every idea I ever had, well, that's kind of bogus, isn't it? But it's okay with me even then. If you're really going to save the world and you completely plagiarize everything I've ever done to do it, that's even okay. It's just a bizarre. I mean, this is just a bizarre comment. You're just saying, what are these trolls doing? I mean, this whole psych game here. Anyway, so let's see. Comment at the expense of yours. Zero-sum game. So he's using a phrase I've used many times. And thus, on the expense of your success. Yes, that's okay. Again, couldn't care less. But in metrocracy, it's cooperation, thus the opposite. Yes, well, that's fine. Like I say, if you've already done all this work, please. What are you? So anyway, so I guess this is just some play proposing some idea that somehow this is about my ego, and that somehow I need to get the credit and all that kind of crap. I mean, none of that's true in the first place, obviously. I've put all my ideas at risk of somebody stealing them in some sense. But clearly also, I've also pretty much established my copyright by making it public. So, I don't know. Anyway, I'll wait for your reply. From my experience thus far, the apes can't care less about the theory of everything. Let's see if you're different. So he provides absolutely no evidence that he has done a single thing that should impress me. So he hasn't even given me a little tiny sample of his brilliance, like just one paragraph of how he's so got it right. And I'm supposed to just say, oh, thank you, Lord, for showing up to save the day. Of course, I will be your minion. Of course, it was all your idea, even though the words are exactly mine. Yes, of course, that's the way it happened. I just don't understand. Why would somebody write this crap? So anyway, so he tried to turn this into something about philosophy, too, which is just so funny, because obviously the philosophy stuff I claim no rights to. So yes, that's all public. Take it. Do what you write a book exactly quoting me. It's okay with me. All right. But clearly the physics stuff. Go ahead and steal it. Right. I'll just point out how you stole it. That's all. I'm not going to just sit there and say, oh yeah, right. That guy thought of it. No, I mean, yeah, I thought of it. But go ahead. I mean, you're free to steal it. I mean, I'm just saying, you could keep all the money from any book you write or something. I don't give a shit about that. I'm just saying, I'm not going to just sit back and say, hey, that guy quoted every single thing I said. He made a video where he repeated every word I spoke. And I'm not going to just sit down and say, hey, I think he just took every idea I had and just rewrote them, right? I'm surely going to make that accusation. So if that's what's scaring you, yes, that's what I'll do. It's, not because I have an insane ego. It's just that, what, I'm supposed to just say go ahead and steal and it's okay, stealing's fun? No, I'm not going to say that, you idiot. People are just such pieces of crap. But anyway, what the fuck is that? I mean, these little petty psych games because he wants to make this into something about my ego. Like my ego is somehow the thing that made me want to vomit when I heard what their explanations were for the two-slit experiment. I said, wait a minute. When I heard them, when I heard the real story, Copenhagen and many worlds, I was like, really? No, I thought you were telling a joke. No, that can't. No, that can't be. That's what they think. And that's the only reason why I'm doing this, shithead. Fuck. Anyway, I mean, I didn't get into this for whatever you think. I knew ahead of time I'm going to be much more brilliant than all the physicists, and then I'll be famous, and blah blah blah. That wasn't how I got into it. I mean, currently in my current circumstance, I'm not saying that would not be nice, but I'm not sitting there. That's not how I got into this mess, fuckhead. And I've certainly earned whatever I get out of it. If anything ever. I mean, I think I'm just going to get it posthumously. Somebody will put flowers on my fucking cunt non-existent grave. They'll throw them in some cesspool somewhere. Good going, Gary. Fuck you, I'm busy. I mean, I'll get some kind of stupid, useless tribute after I'm dead. But whatever. Just so many people. They're just saying, why are you cunts all playing these fucking goddamn dishonest, weaselly games? Shit. I mean, just, it just keeps proving my point. I mean, I keep talking about how humans are not worth it. I mean, they aren't worth 10 fucking cents worth of suffering being endured by a single animal, because humans just can't possibly do anything of merit. They're just such disgusting pieces of scuzz. And they just keep demonstrating it. Keep proving my fucking point. Alright, I'm sure there was another subject, but we'll save it for the next time. And such. So forth and whatnot. Mostly. Yeah, that's enough. Alright, so till the next time. Yeah, there was something else I wanted to talk about, but yeah. There'll be more opportunity, no doubt. Well, there is a doubt, but by probability. No, there should be another video. Is that a heart attack? Alright. It seems like by probability there should, but it's just as likely that, I mean, it's just as there, who knows, snake eyes on the first roll. You just, fuck, probability ain't gonna help you any. Anyway, I mean, it doesn't really get you from, it gets you from day to day, but it does it in such a sneaky way, because it really doesn't do it with any kind of guarantees at all, in a sense. You can roll snake eyes 3 times in a row. It just doesn't play fair, probability. It just doesn't play fair. Anyway, till next time. Such.